And I'm live, and my screen is stuck, which is very unprofessional, ill professional, maybe. Yeah, let me just fix that, and we will continue with our thing. And today we will do day 9 of Advent of Code, which is just this. And yesterday we had written some lines. So, what was the thing that I concluded yesterday? Give shortest path. Okay, this much. Yep. All of this code is just the boilerplate, and now here at this point, like at line 34, I have to add something which will actually solve the thing line by line. And what was my thing? What did I thought that I would do? I would save these in a key value pair in which the key would be the name of a place and the value would be an array which would contain the which would contain array which would contain the places that this current key is connected to, and to store the places in the array I will store a pointer to their name, right? Yep. And then there will be another, so the structure would be something like this. Hmm. Type diff type struct. Yep. Key, I'll just call it key, char pointer key, yes, char pointer key, yes, and then a pointer to arrays. Is that cool? I want to keep a list of numbers, and yeah, so I can just do int weights, and this will be an array of size 30, which is greater than all the weights that there are. So this should be cool. And so instead of storing the places names as key value pairs, should I store them as a number which will be mapped to them, to their integer value? I can write a hash function which will take in a string and give out a hash, and hashes will start coming out at 0 and will go up whenever they encounter a new string. And I will write an anti-hash function which will give me the string for a hash. Right, that would make sense. So instead of this, I can make this integer, which will be the hash integer, and this would be the place. And then, yes, after weights, I can store the places that this thing is connected to, or just this here. Index 0 would mean the weight for its connection with the zeroth thing and stuff like that. Okay, I cannot assign anything. That is okay. Right. If that is the case, I don't need anything else. If there is a connection between two places, then there will be a non-zero value at that index in the current thing's structure. So I can call this a node. Yep, I can call this a node. And there will be a global array which will be mapping, which will contain in itself pointers to characters. Yep. Char pointer and global places, and it would be 30 pointers long. And now a hash function which will return an integer that will be the hash for the string, and get hash, and it will take in a char pointer, a null terminated char pointer, and it will be called s. Yeah. Now I need to check if the current thing exists in the table or not. Yep. If the current char that I got, does it exist in the table or not? Right. And also one more thing, I need to keep track of the index of the current index in the global places thing. So int index equals 0. Why redefinition of index? Where am I defining index? Okay. Here I can make this L index, that is like line index and stuff. L index, and this also L index. 28 redefinition of index. Where am I using index again? Am I using index? Redefinition of index. What do you mean by redefinition of index? Where am I using index again? As different kind of symbol. Let me use not index but current index. That is cool. Yep. And make this back to index. Yep, that is cool. And yeah. So here I'll make a for loop, or I can make another function which will take in a string and return me the index for it, which is just nah, 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 which is not right. Right. For int I equals 0, I less than current index I plus plus. What do I want to do? I want to check stir compare. I want to check two strings. I will pass in s, and I will pass in the current string in the global places array, global places I. The value written by this function should not be disregarded. Neglecting it may lead to errors. So what does stir compare nc return? Stir comp 0 if the strings are exactly the same, and that is what I want to check. If this thing if this equal to 0, then break, and at the end of the loop I will check if I equal doesn't equal to current index, then I know that I found a match, and I will just return I. Is that correct? Oh, okay. And I remove it. Yep. And if I did not find a match, then I will do global places current index plus plus equals to that pointer, or maybe I should malloc and copy the string to the to the heap and then store it so that I have a better chance of keeping it there and do not have to care about the context and stuff. Right. So how do I find out the length of the string? Shit. To getting the length, I do for int for I equals 0, I less than nope, si is not equal to backslash null and I plus plus. Then yeah, at the end of this I will have the string. Yes, at the end of this I will have the length of the string in I. Now a char pointer a new string equals char pointer malloc size is I, right? And again now I will copy it for I equals 0 si does not equal to null I plus plus to new string I equals si, and after it do new string I equals null character. That should be cool. And here instead of doing copying s, put in the address of s, and what do I want to return? Return current index minus 1, right? Yep, current index minus 1. This will get me the hash. Now if I have the hash and I want the string get name, this will take in an integer n and return the hash. If n less than, no, this will not return an integer, this will return a char pointer. Char pointer. If n less than current index, then return global places n, and else what I want to return, if that is you are giving me a number which does not yet exist, then just return something rubbish. What do I want to return in that case? Can I not return two types of things? Nope. I will have to return a char pointer. Char pointer e, and return e. That is like uncool, but that works. That will give me error, but that works. So it is fine. Now it will be much easier to work with this than compared to what I was doing before. Now, yes, what do I want? In here, yes, first of all, I want to parse the command, parse the line into a pointer into two strings and one weight. Yep. And so let me define the structure for that. So a node looks like that, and type def. Where will I be storing the nodes? How will I be storing the nodes? I want to store the nodes, like pointer to nodes in some array, and where, yes, I will have to initialize an array in which the hash will be the index to get the node for that specific. No, there are multiple nodes there. Oh no, there are as many nodes as there are places to go from. Yep, there are as many nodes as there are places to go from. That is cool. Yes, there are as many nodes as there are places. Right, right. So I will have to find a way to get the nodes for the places. Therefore, I will. What does this contain? This contains a global places string, right? Yes, right. Global places string. I will make this also string, and this also becomes string, and this also becomes string. Yep, yep, yep. Type this now. Yeah, and I will define array, another array which will give me the node for a specific hash for a specific place. And to do that, to get to a node from a place's name, first I will have to call the hash function to get the hash, and then I will have to query the table to get to the node. So what will this contain? Node array global bulk nodes, and let's say 30. 30 is the length, an array of nodes. That is cool. And structure, and am I in the middle of the screen? Yes, I am. And a structure for a command, and char pointer. Char pointer, or should I directly deal with hash? That would be cool. Yep. So integer source and destination. This is directed. Fucking hell. Wait, is this actually directed? Like Nora? Do I ever get Nora to this Firun? If this is directed, then that changes a few things. Well, not. It might change a few things. Tumby to Skylight. Is there any? Nope, nope, nope. Is this directed? If this is directed, then no. If this is because this should could be directed because this is two, right? Two. So, but that does not make logical sense because getting to a place, should I got logged out somehow? Log in, and do I want to like hide this login screen? Nope, it just works. That is cool. Day number 9. The possible routes, therefore, are these. Dublin to this, London to Belfast, Dublin to Belfast. Yeah, so I would treat this as non-directional. This year, however, he has some new locations to visit. His elves has provided him with distances between every pair of locations. Yeah, so it is not directed. So yeah, um, I can do integer for place 1 and int place 2 and int weight, and this will be called a line will be called your um, mm, should naming things in programming is hard. Distances between every pair. Okay, I will call this distance. distance. Yep. And now what do I want? What do I want? Nope. That is what I want. And is there something else that I want? Nope. Nope. At least not now. Right. Given a line, I want to write a function that will return me distance and find find distance. It will take in char pointer s and return the distance. And by malloc, distance pointer this equals uh, distance pointer malloc size of distance, and at the end return this. It returns a pointer to a distance, not the distance itself. Right, right. Now I have a move. What do I do? I will start from 0. Right. I want to. What do I want? I want to find hash for things. Right, and store the hashes. So for int I equals 0, I less than not si is not equal to null character I plus plus. What do I want? Yep. Uh, I want the first string. I want to send the first string to the get hash function and get the hash and store it in the distance. Then I want to send in the address of the first letter in the second string and replace the next space with the null character and get get its hash and store it at the end. And then I want to get the number at the end and store it in the weight section of the distance. Right. So I guess I can create a variable which will tell me the state, and state equals 0, starting will be at 0, and I will say state equals 0 implies first place, state equals 1 implies second place, and state equals 2 implies that I am in the weight section of the thing. Now, if what I encounter is a string, is a space, if si equals to space, right, then I want to check a few things. If state equals 0, that is, this is the first time that I am encountering a space, I want to do this dot place 1 equals get hash for s, and wait, I got this. I have to do si equals null, so that this can terminate. Yeah, yeah, that is cool. And then I'll do state equals 1. Right. Else if state equal to 1. Right. If state is equal to 1, then it could be 2. It could be the space after 2, which I would like to ignore. Right. And how would I do that? How would I ignore it? Wait, and I also want the address of the start. Okay, this is the thing after n. Okay. So this this piece of code will be reached when I get at the space which is after to, and when I am there, I want to get the address of the next character, which is the second place, and put a null at the put a null character at the space which is before the equal to sign. So for nothing si doesn't equal to space I plus plus. Yep, that is good. And here I will do char pointer second place equals address of si+1. That does work. And now here I is at the space. I can do si equal to null character, right? And this dot place 2 equals get hash for second place, right? Right, that is cool. And at the end, do state equals 2. Now, if I encounter a space and state is equal to else if state equal to 2, then I know that the remaining part is a is a number. So I have to write a function which will give me a number. Int give me a number for a 2i. I can just call the library made function for this. This dot weight equals ATOI char pointer. Char pointer is the address for si+1. Yeah, and then I can just leave. Yep. Return this at the end. Now I want to call this function for every line. Right here. Right, function declarations come after this. Yep. Call this function for every line, that is here. Find this for line and distance, right? Distance equals to this. Okay, distance pointer is this, or I can just go to this. Right, now I would like to print the distance. Printf place 1 hash is %d something, place 2 hash is %d something, and weight is %d, and the new line, and then distance dot place 1 comma distance dot place 2, and then distance dot weight. Let's see, that should work. Blank part not 2 but part 1 dot c, send the output to dot slash out. Let's see, and it goes out of bound. That is crazy. Yes, makes sense actually, because 52 here index equals 0. It has to be equal to 0 at the end. And yes, am I getting something? Yes. So hashes start at, yeah, that is perfectly amazing. Okay, hashes are going up to 34. So do I really have that many places? No, no, I really do not have that many places because places are repeating, right? Um, Here I have term B. Here again I have term B at 71 and at 49. I should have the same hash. At 71 I have 6 and at 49 I have 19, which is not correct. It is wrong. Mhm. But in this case I am getting the hash fine, just fine. So something is wrong. The way that I'm calculating the hash for the second place. Yep, the way that I'm calculating the hash for the second place. Let's see. When I do this, I would like to printf second place percent s backslash new line second place blank. Let's see what is the mess up. Second place is thumb equals 18. Okay, it is going till the end. Okay, that is not what I wanted. Up here, second place si till I see space, right? Till I see a space, that should have happened. I plus plus, but that did not happen. And then still, how am I getting uh, the weight correctly if this is not going on fine? SI second place, yeah, it is going till the end. So what is the value of I here? Let's see. I is percent D, and here I'll make it equal to I, make it print I, and let's see, right? I is 16, 8, 8, 8, 8, okay, 10, this goes till here, right, which is not correct, which is absolutely not correct. Here in the last thing I is equal to 8, in the last thing I is equal to 8, that is 1, 1, 2, 3, 4, 5 characters in Thumbi, but it is 0 index, so 4, 5, 6, 7, 8, 8. So I is still here at the space. It did not increase. That is the problem. I did not increase when I did this. So SI, while SI is not ow. Okay. Because it is at space, so this should do it. Yep, that does it. 52. Not this. Remove this. Don't print this. And let's see. Yep, that works better than before. So here at weight 67, I'm getting the hash 7, and at the end also I'm getting the hash 7. So they should be the same things. At the end I am getting starlight and weight 57. 57 it was, right? Uh, 67. Yep, it is starlight. So that is cool, and I'm able to parse the commands. Now I want, after parsing the commands, to create nodes for commands. Yeah, distance does not seem great, right? So let me change it. Percent G. Is it G? No, it is percent S slash change distance to change it to command in the whole line. Command, find command. Yep. Are there any problems? Nope, none at all. Now, yep, after getting the command, I would like to find a way to create a node, a function that would take in a command, create a node, put the pointer to the node in the right location in the in array, which is storing the pointer to nodes for every place, right? So this will return nothing, and it will be called execute command due to some reason, and it will take in a command, or a command pointer. Command is okay. It will take in a command, and it will be called cmd, right? And yes, I have place. So first of all, it will see if there is already a pointer to that thing or not. For this here, I should first of all initialize all of it to point to 0 to have the address is 0 inside of them. Global nodes, yep, it is the name. I will point make global nodes equal to 0. It is 0 at the start. Yep, global nodes is 0 at the start, and global places string. Yep, global nodes is 0. Yep, and in execute command, I have the hashes for both the things. First, I will see for the first place if cmd dot no, global nodes cmd dot place one equal to 0, that is a node does not exist for it. Then I will do malloc um a node pointer node 1 equals node pointer malloc size of node, yep, size of node, and then node 1 dot place. What does place contain? Place is the hash, right? In the node place, yep, place is the hash. Place contains the hash, which is equal to well, just cmd dot place one, right? That is cool. That is cool. What is invalid? If global node cmd equal to 0. Ooh, global node. What is global? Oh, it should be a pointer to nodes, not nodes themselves. Now it will give me no error. Yes, and here, then after initializing a node, I can just put it into global nodes. Global nodes cmd dot place one equals node one. Right. So I have the first node in which I will add the address. Fucking hell. Yep, I will add the address. I will add the weight for it. Yeah, and which is simple. I can do just here node one dot weights, and in the index, what is the index for this? cmd dot place two's index equals to cmd dot weight. That is crazy. I have to just do the same thing for the second node. And yes, also there is also the else part of this, which should be equal to since I already have the node, so global nodes cmd dot place one. Yes, I got the place one. Then dot weights bracket cmd dot place two equals cmd dot weight. That is a crazy statement. And after that, I will have to do the same here, but just change one with two. One with two, change one with two, change one with two, one with two, and change one with two, and also change two with one. This changes to one, this also changes to one, and shit, I forgot which one changes to one. Yeah, this should change, this should be 2 as it is, and this should be changed to 1. Okay, there are some place. Uh, node 0, if a node 2 does not exist, then I will malloc and get a new node, and I will make it so that node 2 dot place equals cmd dot place one. Yes, it contains the hash for itself in this. And then global nodes place 2. Now I have put it in the global nodes thing, and now I want to do nodes 2 weights. Wait, fucking hell. At the end, I will have to find an algorithm which goes through all the nodes. The shortest algorithm which goes through the shortest path between any starting and ending node, which goes through all the nodes exactly once. Isn't that a bit too complicated? Like traveling salesman problem. The shortest of these is this. Okay, these are all the paths which travel. Fucking hell. So to get from Dublin to Belfast, and in a way that it takes the fast, so I have to find the fastest way to get from Dublin to Belfast so that I cross every single location, right? Which is crazy, which is actually crazy. And why is this different? Wait, London to Dublin is 464, right? I add London to Dublin 464 plus Dublin to Belfast. Dublin to Belfast is 141, right? This gives me this. Then Dublin to London. Dublin to London is 464, right? Yep, and then London to Belfast is 464 plus this number, which is okay, yeah, fucking hell. So this part, what I'm writing right now, is just to make a structure which stores the information that has been given to us. Yep, and node 2 dot weights, and inside the weights for place one, I make the hash equal to this, right? And then global nodes, I make this equal to this. Come on, place two, for place two, if I already have the node, I make the weights place one equal to weight. This, yeah, that is cool. That is cool. I would like to execute that command for every command. I would like to call that function for every command that I get here. Execute command and give in command. Yes, yes, that should be enough. And after that, when I have executed all the commands and I have a data structure which stores all the commands, which stores all of this data, I would like to print something. Nope, I would like to find a way. Ah, fucking hell. Yes, so I have to write in a function which, given two places, a starting and an ending place, will give me the shortest distance it takes to go from the starting place to the ending place in a way that it goes through all the places once. Right. So that it goes through all the places at least once. And why are these different? Right? Some of them are, yes, half of them are same. Let's say if the order is same, what is keeping them same? Okay, I just reversed it in this thing. Okay, and if I go from London to Dublin to Belfast, okay, what is the thing that is actually changing the thing? What is the thing that is actually changing the address, making the address to change? Let's see. I have this, right? And then let's say London is here, then Dublin is here. Well, which is, I don't know where is Belfast. Belfast. Where the heck is Belfast? Oh, Belfast is here. Okay, and which is in Northern Ireland. Okay, so it is, to be geographically correct, it is more like London is here, Dublin is, oh shit, Dublin is here, and Belfast is somewhere here. Maybe a little bit here, and then Belfast is here, right? Now, this distance, Dublin to Belfast, is 141, and this distance between Belfast and London is 518, and this distance between Dublin and London is 464. And let's say, what are the combination of starting places? Combination of what are the all the permutation of places that we can visit is this, right? So the question is, why is this distance different from this distance? Why is this different from this? Here I start at Dublin, I go to London, then I go to Belfast. So I skip this. So I'm skipping this. Okay, and in the other way, this is fucking crazy. Okay, so I just have to sum all the weights, and to get to find the answer, I just have to subtract this distance from the total to get this. Fuck, fuck. Okay, which is cool, which is actually fucking cool. This is so easy. This is so easy after seeing this. Let me just confirm this. Now, in a second, I go from London to Belfast, and then to Dublin. Yes, so what this theoretically means is, I guess this. Let's say I have a bunch of places. One, two, fucking hell. I thought like it would be really, really hard to know all of this, to make an algorithm that will go through all the places and do stuff. But you can be smart. You can be smart. You can study the problem and do stuff. Fucking hell. This is so fucking cool. This is actually cool. I do this, and so every node, every place is connected to every other place like that. Wait, don't I have colors? Yep, I should have colors. Let's say stroke. Yeah. I start from, yeah, and they also have weights and stuff, and each line has some weight. Okay. So let's say if I start at 1 and I want to go to 2, so there is, of course, the straight way which I can take, and then my total distance would be equal to, hey, fucking hell. Nope, 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 nope. My initial algorithm was wrong. Yep, yep, yep. That is wrong. That is wrong. Yep, yep, yep. Yeah, yeah. Fuck. Fuck. I got too ahead of myself. Shit. It seemed correct because there were only three places here, but with more places, it will not seem correct. Yes. So to get from A to 2, 1 to 2, yeah, fucking hell. I can either take the straight path, or second, I have to take a path which goes through all the nodes. Right. So I get to a node, and then I get go to another node, then I go to another node, and then I go to another node. This is the second way I can choose to do my thing. That is, I go here, then I go here, then I go here, and then I go here. But then there is also this path in which I go here first, then I go here, then I go here, then I go here. Right. How do I figure out the smallest one among these? And there is also this in which first I go there, and then the remaining. Okay, well, isn't this a greedy algorithm? Fucking hell. When at a particular node, I have multiple options. I can go to any of the nodes which are remaining, which I have not already visited, and among them, which one should I choose? I shit, battery. Okay, let me get my charger. Just a minute, and let me get my charger. Yep, I'm back, and yeah, my initial algorithm was wrong. In that I thought that to get the shortest distance to get from here to here, I just have to subtract this intermediate distance. But when there are multiple things like this, let me just expand this. Yeah, that is not what I wanted. So yeah, I have to create an algorithm which does a few things. Let's say I have multiple places. White is good. Well, not like in a racist way, but it is good. Let's say I have multiple places, one, two, which are spread across space and time. Three, four, and five. And every place is connected with every other place. Like this, this is connected with this, and with this. Now, here, 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 and this, and this. So, this is a complete graph, right? This is a complete graph. And here, the number of edges, degree. Degree is one less than the number of nodes. Mhm. So my task, well, is given a node starting and an ending node. I have to figure out a way so that I can get from here to here going through all the nodes. And how do I do that? Well, I will keep of a list where I keep track of all the nodes that I have been to. So I will start at this starting node, of course, and then I will see the nodes that I can go to. From the first node, I can go to 3, 5, and 4. Let me also give them some weights. 1, 5, 10, 15, 3, 6, 50, 3, 2, 69, 100. Is that weights given to all the nodes? The weights have been given to all the nodes. Now, given at a node, how do I decide which node should I go to next? I can use a greedy algorithm, which goes to the smallest edge, but then it could also mean that, let's say I go to here, and after this, I can take this and go here, and take this and go here, and then take this and go here. Greedy algorithm will not work because I want the shortest one, right? Greedy algorithm will not work in this case. So, do I do a DFS? Do I actually have to compute all of the possible ways to go from here till here? I have three nodes, right? So I have in total five nodes, and I'm taking two nodes, and I'm taking one as starting and the second as the end node. So what I have to do is decide a way to traverse between three nodes, which will give me the shortest path, the shortest distance. And from the end, wait, isn't that recursion? Wait, to get from this to this, I have to get from this to one of these, and from the end I can go there. But yeah, but how do I figure out which one is the one that takes me the shortest? Well, I can use recursion. I can calculate this for all of them, calculate the path to get from here to all of these, right? And I will mark this as visited, all of these, right? Right. Yeah, but I do not want to go. to node 2 ever in any of the possible paths. But when I'm checking for 3 and then I'm subdividing that into, let's say, 5 or 4, I want to go to 3. Wait, no, I do not want to go to 3. Yeah, that is cool. That is cool. I can use recursion here. So to get from 1 to 3, I have to find the smallest path from 1 to 3, 4, and 5 and see whatever is the smallest. I will go from that node to node number 2, right? And how do I get the smallest path to get from 1 to 3? And I will say that do not go to 2 when I am finding the smallest path for 3, 5, and 4, right? And it will keep breaking the problem smaller and smaller pieces. Yeah, that is cool, right? And yep, yep, yep. And so when let's say I get to 3, I have to find a way to get from 1 to 3 in a way that in the smallest path in a way that I cross all of the nodes, right? Uh, so to do that, I have to find a way to get to 5 and 4 starting from 1 in the smallest way possible. And I will go from that node, that the smallest path to get to that node plus the path to get from that node to the current node, right? So here I will see that to go from 1 to 4, the weight is 5, the cost is 5, and to go from 1 to 5, the cost is 15. I will get 5 and 15 for 4 and 5 respectively. Then I will add the distance from 4 to 3, that is 3, and I will get 8, and I will compare 8 with 15 plus 69, which is obviously greater than 8. So I will say that to get to the third node, the shortest path which goes through every node, every remaining. Fucking hell, fucking hell. Yeah, okay. When I am finding the way to get to node 3, the shortest way to get to node 3 from node 1, I also have to include, the path has to include both of these remaining nodes, right? So, yeah, both of the remaining nodes. The path has to go through 5 and through 4, right? So, so it was my mistake. When I said that I want to find the shortest path between 1 and 4 and between 1 and 5 so that I go through all the remaining nodes, I have to find a way to get to 5 so that I go through 4 and get to 5, which is this is the only place, only so I can check if there is only one remaining node, then the shortest path is just a single this. So to get to 5, I will take 5 plus 100, which is 105. And to get to 4, I will have to go through 15 and 100, which is 115. Right. So now for 4, I am getting 115 and adding 3 to it is 118. So getting to 3 in this way, in this manner, is 115. And then getting to 3 in, wait, this manner is greater than 115. So for 3 to get to 3 by passing through all the nodes, this is the shortest path. Yep. And I will do the same for 5. For 5, I will find a way to get to 3, to get to 3 and to get to 4 by passing through all the remaining nodes, which is to get to 3, it is 5 plus 3, that is 8. And to get to 4, it is 53 plus 3. And yep, and I will return those to 5. And the algorithm when at node 5 will get 5 plus 3, 8 for 3. And 8 plus 69 is 77. It will get 77 for 3. And for 4, it will get 53 plus 3 plus 100, which is obviously greater than 77. So to get to this, the shortest is 77. And what was the shortest for this? It was this. It was 15 plus 100 plus 3. Yep. 15 plus 100 and 3, which is 118. Right. And to get to this, I will do run the algorithm again. Which I want to get to 5 going through 3 and 3 going through 5. So for 3, node 4 will get 15 plus 69, which is a big number, plus 3 it will add on its own. And for 5, it will get 53 plus 69 plus 100, which is greater than the other one. So the answer for this would be 15 plus 69, that is 79, 84, 84 plus 3, which is fucking hell, 87. So I will get 87 for this. And now when I am at node 2, I will get 118 for this, 77 for 5, and 87 for node 4. Then at this, I will add 10. I will add 118 to this, 10, and 77 to this, 6, and 2 to this, 87. And the smallest, obviously, is this. So the smallest weight to get from 1 to 2 is this path, 6 to 7. 6, which is 83. That is cool. And I will have to do this for every single pair. I can use dynamic programming with recursion. I will keep a memory where I will store the shortest path between every two nodes that I'm going through. Right? That would be cool. That would be cool. That would be cool. But what if my algorithm is messed up? It is messed up. Well, if it is, no, it is fine. It is fine. I will be using memory. And how will I be storing the thing? How will I be storing data into the memory array so that I can check, have I already found out the way to get from node 1 to node 5, the shortest way to get from node 1 to node 5, let's say. How will I store that into the memory? Well, I have to store three things. S- Start and end. No, start and end does not matter. Place 1 and place 2 and the shortest distance, the weight, which is I guess 77. Yeah, which is 77. And how will I check for it? Have I already found between 1 and 5 or 5 and 1? The order can change. If the order changes, that does not change anything. It will still be 77. I can go the other way around. Like, I guess it was like this. Yep, it is like this. I can go this way. This is on direction, so the direction does not matter. So how will I find out if I have already found out the shortest path? which goes through every single remaining node. I will go through the array which contains them. Or no, 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 no. There is a better version, I guess. Yep, I can store them in a matrix. Right? Yep, I can store them in a matrix. In a matrix, but, yeah. I can store it in a matrix and then I can query the matrix if it is 0 or -1. If it is -1, then I have not found it out already, and if it is if it is not -1, then I have already found it out, and if it is -1, then I have to find out the shortest distance right now and put it into the matrix. Hmm, that sounds cool. And the matrix would be like something like this: 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4. Ah, fucking hell. There should be no 0. No 0. Yep. And to get from 1 to 1, it is 0, and I actually do not care about these diagonal elements. Let's say, and to get from 1 to 2, the shortest distance that we have found out is 83. So 83 will come here, and 83 will come here. Somewhere, right? And to get from 1 to 3, 1 to 3, 1 to 3, or 3 to 1, 1 to 3 would be 1 2 3. What was it? It was 118. Yep. 118 and 118 here. To get from 1 to 4, the shortest was 87. Here also the shortest was 80. Fucking hell. But, 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 the shortest was 118 and 87 when I was not going to the second one. When I was not going to the second thing. Fucking hell. Yep, when I was not going to the second place. Brr, brr, brr. So how can I benefit from this fact? No way. No, 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 no. So will the array even help me storing the memory? How can does the sub problems which I am calculating, do they overlap? They might in some cases, but how do I figure out those cases? Ah, fucking hell. This is not fuck. First I thought this could be pretty easy, but then nah, and now it seems to be hard. Okay, what is the basic problem? The basic thing is that I have some nodes which have connections. I have a complete graph, right? And the edges have weights, and I want to figure out the pair of nodes, the pair of nodes which have the shortest distance when I go from one node to the other. Okay, what are all the possible distances? What the heck am I even talking about? Yeah, I can go from one node to any number of nodes. Fucking hell, yeah, I can use recursion in doing that. Uh, yeah, I can use recursion, but then The sub-problems do not overlap in recursion because finding the shortest distance between 1 and 5 when I want to go from 1 to 2 will uh, will mean that I want to find the shortest path between 1 and 5 where I do not visit the node 2. But that is very specific to the case when I want to go from 1 to 2, right? So there is a memory overlap, but then I think it would just reduce, it would be much better to just find out the answer for myself, the answer, to calculate the answer, to compute the answer instead of checking if I have already solved it or not, because this is 2D. I would want to store the answer in 3D. Third dimension would contain the number of excluded nodes, the list of nodes which were excluded, right? The list of nodes which were excluded. Yeah, right. Mm, 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 mm. Or there is also there was also this way in which elements are like this, starting from index is 0, 5, 6. Nah, 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 nah. I have to write an algorithm, figure out an algorithm which will give me the shortest path. Even if I do not complete this, this is very good. Just thinking up, giving time to a problem like this and thinking about it. This is improving my skills, right? This is improving my abilities. I don't know. Getting to the result is not the best. Well, getting things done is important, but here I'm just messing around. Or maybe not. Yeah, I have to give this some importance, and this is helping me. So, okay, okay, this is okay. Yeah, I have to figure out a way, an algorithm which gives me the shortest path from from a starting location to an ending location so that the path goes through every single node. Okay, yep, yep. So to get here, the different paths can be, let me make this a new one, two, three, uh, four, and five. Yep, and I will give them weights and stuff. And this is the way that every single node is connected to every other node, which is just crazy. Every single node. Ah, shit. That is a very bad connection. That one is much better. And yep, here we go. And the weights, yes, 1, 5, 9, 10, 20, 100, 2, 7, 37, and 89. Right, I have given weights to get from 1 to 2. There are multiple paths. I will have to go through 3, 5, and 4, and then finally to 2. So how many edges do I have to go through? Here I have three edges, and at the start, I cannot go to two directly. At the start, my. At the start, I have three choices, so I can choose among three things, one thing. So right now, I am trying to calculate the combination, the possible number of ways I can go from one place to another. Here, let's say the total number of nodes is n, and when at the starting node, I can go at how many there are. The degree of a node is n minus 1. I guess the answer should be n minus 1. That is 5. Here, there are 5 nodes, and every node has 4 connections, 4 edges. So the total degree is n minus 1. And at a particular position here, I have three choices. That is n minus 1, minus 1 choices. And then after making a choice, I have two possible choices. That is multiply by n minus 1 minus 1. So the answer should be n minus 2 factorial ways to go from one node to another. Okay, and that is quite a bit. If you the number of nodes is greater, and I have to do that with every single pair. So multiply this by every single pair of nodes. For the first one, I can choose I have n possibilities, and for the second, I have n minus 1 possibilities. That just comes out to be n factorial. So n factorial things I will have to do, which is just crazy amount of things. So I have to find out a efficient algorithm for this. And like, even if I am unable to figure out an algorithm today, I will skip and move on to question number 10, because I'm studying algorithm from the algorithms book, and I do not have to I do not have to be too hard on myself, because the main thing is that I am reading algorithms from one place, and I do not have enough knowledge about algorithms, I can say. But yeah, you can say that after putting enough brain power, I will be able to figure out whether efficient or at least correct algorithm that does what I want it to do. But that would take a lot of time. So I can be a little smarter and spend some time, like I'm doing right now, on figuring out the algorithm, and then spend and do not be hard on myself. And because I know that I'm studying the algorithms, and I will be able to figure this out after studying the algorithms. Hmm. Now, to get from here to here, let me mark all the possible paths. One is this, right? There are n minus 2 factorial paths, right? So there n is 5, n minus 2 is 3, 3 factorial is 3, and 2 is 6. There should be 6 paths to go from here to there. Okay, one is this, one is this, and one is certainly this, and another one is if I just go there and then I go to 3 instead of 5, and then go from 5 to there. Yep, there are about 6 paths, and What makes a good path? Let's analyze only one of them at a given position. Right. I want to go from here to here, and I have three possible choices. Which one should I take? There is also the recursive approach in which I to get from 1 to 2, I have to find the smallest path to get from 3 to get from 1 to 3, 5, and 4. I guess I will okay, I will write the code for that recursive approach and without using any memorization because using memorization would be a lot of unnecessary work which I feel like which is not really good for my use cases because the total number of nodes in my case is it is 13. The total number of nodes is 13 in my case. Wait a minute. The last one is 13. Right. Last one is 13. That is, go to the puzzle input. The last one, Tambi, is 13, but I got Tambi here at 71. Why is it 13? Tambi at 71. Here it is 6. So why is it 13 there? There is some mistake in figuring out the address for the first one. Wait, are there any addresses which come from here to the nope, nope, no, not repeating. Okay, find command. Yep, this is messing up, and let me do printf first print s backslash new line and what s clang slash out. Okay, yeah, I'm getting a space. Am I getting a space before or after? Let Tumby right. Tumby. Tumby, how is this Tumby different from the second one? Or am I messing up with the way that I am calculating the hash for the second place? Right. Let me remove this and put a on this, but this character here, this character here, and when I am going through this, I will do not S, but I will give in second place, and this is the second character. Right, let's go. Thumb. Okay, second one is thumb. Okay, I am not taking the last snow D. What is snow din? Okay, I am terminating beforehand. Right, that is wrong, not right. The second one, I am messing up in the second one. Okay, so yeah, wait. Si is Si is a space. So wait. Okay, after doing this, doing this, Si is should be a space. Si should be a space. Mhm. I should be a space, but it is not. Plus one. Right. Clang. Dot slash out and yep, 6, 7. So I have 7 places. So there's not too much. What if they increase the input size? They won't increase the input size. I am uh, slang dot slash out. They will not increase the input sign. Yep. This is cool, but fucking hell, fucking hell, fuck. Weights are zero. Weights are zero, which is not good. Weights are zero. Find command. This is messing up the weights part. Hmm. Okay now. Hush. It messed up again. Find command. Alright, I got I and then I got the hash for displace. Second %s to print a string, new line, and here put the second place, right, and do the same here for first. Make this s and do the same with weight. Printf weight this %s this backslash new line comma given the address of s I plus 1. That should work, and after that just put a new line so that we can be happy. Right, weight is 99. For this 712 star LIGH T, it should have been, there should have been a T there. Okay, so I am messing up at some place in this second command. After this, okay, second place is good. Second place is good, but then the way that I am putting in the null character is wrong. That seems to be wrong. Hmm. This null character should terminate at a space when the index points. When I plus 1 points to a space. Okay, so I can do I plus plus here and just go from I here and do this and do I plus plus. Right, that should put me out of my misery, and that actually does put me out of my misery. But does it? No. Yep, it does. It does work. Slash out. Yep. Yeah. I'm getting the correct weights. I'm getting the correct hashes. This is cool. The maximum goes up to 7. It's cool. Yeah. Yeah. Then I start at 2 and go up to 7. Then I start at 3 and go up to 7. Then I start at 4 and go up to 7. Then I start at 5, go up to 7. Then at 6 till 7, and then finally 7. Now, given a pair which says start and end, I want to figure out the shortest way to travel to travel between them. Give shortest path. Give shortest path between any two pairs. Okay, so I will have to go through every single pair of pairs. Shit, which is n minus 2 factorial things. Shit. For okay, so how do I get? I would also like to have the maximum number of the total number of nodes, which is an nodes node count equals node count for int I equals 0, or for node count equals 0 in global nodes till global nodes node count does not equal to 0, and just to node count plus plus, and yeah, then printf the number of nodes is %d backslash n, and node count clang dot slash out. That is a lot of things. Why am I printing it? Ah, print it here. There, yeah, yeah. Clang, and we'll see it again. Yeah. Number of nodes is 8. It's pretty cool, right? And now I have the number of nodes. Now I would like to for int I equals 0. The maximum hash is going to be less than the number of nodes, which is 7. So I less than node count I plus plus, right? And inside for int j equals I plus 1, j less than node count j plus plus. Now I have the hash for start and the end. Miserable. Because the thing is that I have to go through all the possible nodes. I cannot take the shortest distance, which is like theoretically the shortest, and I can take any number of paths that I want to. I can just go maybe even directly there. I cannot do that. In here, I had to go through every single node to get to a place. Now, I will write a function which will give me the sum, right? So let's say I will define a structure, uh, uh, type def struct, which will contain integer for start, integer for end, and integer for distance, and it will be called a pair. Now let me declare a function, execute command, nope, in here, a function which will return a pair pointer, because it will be mallocing stuff. It will return a pair pointer, and hmm, can can it return? Oh, yeah, I have to check a thing about C language. Maybe I also checked this before. Let's say I have a, yeah, I checked it before yesterday, right? returning local structures in C. Yeah, if I do something like this, declare a structure inside something and then I return it, then I will see unexpected behavior. Yep. So I should do malloc and use pointers. Right. I want to return a pointer to a pair pointer. The function is find shortest path, and it will take in integer start and integer end, and let's declare a pair pointer called, this is going to be the end, right? The smallest pair equals pair pointer malloc size of pair, and at the end return smallest pair. Let me define this above here, 6, that is cool, and I will call this function from here. And yeah, I will also have a pair of my very own, right? A pair of my very own, which will be a pair pointer created using malloc. The smallest pair equals pair pointer malloc size of pair, right? And yeah, I will call uh, pair new current pair equals find shortest path, and a start is I and end is j, and since this returns a pointer I will say go to there, and now I will compare the distance. If the smallest pair dot distance is greater than current pair dot distance, then the smallest pair dot distance is greater than the current pair dot distance, then smallest pair dot start equals current pair dot start, and smallest pair dot end equals current pair dot end, and smallest pair dot distance equals current pair dot distance is cool, and then free the current pair because malloc and fuck. So I should do this and make this a pointer so that I can free it later. Gonna replace this with this, replace this with this. Right. And at the end, I can just return smallest pair, which is a pointer to a pair, and thus I will have to change a few things. Make this a pair pointer and make the change here also, which is where is the function? Find shortest path, execute command, find command, global node give shortest path. Where have I declared that function? Well, at the top. It's crazy. And yeah, make this pair pointer and change this to pair pointer, and instead of just blindly doing this, do I'll do start, which is a number, and then end, which is a number, and then distance, which is another number in itself, and start is start, and answer dot end is end, and answer dot distance is distance, and again I will just free answer. No memory leaks at all. That is cool. Now find shortest path. I have to execute this. Given a start node and an end node. And one more thing. This function will also like to have an integer or character or an uchar array of visited. Right. Uchar array of visited. And let me make type def unsigned signed char to uchar, and change the type in here uchar array. Is that good? Yep. And in here let me give in an array which is uchar visited equals visited array equals I comma j. No, 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 no. No, 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 nope, 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 nope. Visited does not work like that. I have to. Shit. Unsigned array of size node count, and do this. Visited bracket equals I equals 1, and visited bracket j equals 1. And in the end here, given visited. Visited, 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 visited. Now I want to get to a point. I will see the remaining number of nodes, right? I also want to know the remaining number of nodes. Okay, I will also take that in input. That would be cool, right? That is cool. That is cool. They would not object now, comma visited, and remaining count is what I will call it. Integer remaining count, and above integer, or just remaining count with the okay, remaining count. What is remaining count? Remaining count is node count minus 2, right? Because I have to visit 3 nodes, right? If the number of nodes is 5, and when do I reach an end case? Let's say in the first iteration I give 3 as remaining counts, and in visited I have put in 1 and 2 in visited, and start, let's say I go to 3, and start is 1 and 3 is the end node. That is the first time of the iteration. And then let's say I go for the 5. I want to get to 5. Starts at 1 and goes to 5, and the visited now contains 1, 2, and also 3, and then remaining count becomes 2, right? And then 3, let's say from 3 I ask for how to get to 4. So now this is what I get, and the visited contains one, two, three, four, right? No, 1, 2, 3, 5, and visited is remaining is one. When remaining is one, I can just return the weight of 1 and 4. Return the weight of 1 and 4. That's cool. So if remaining count equal to 1, then what do I return? Yep, I return a pair. A pair is what I return. Return, no, first change the pair. Find shortest path. Find shortest path. Why do I need the start and end to be returned here in this function? I can just find the sum because I myself, the caller of the function, knows the start and the end, right? I can just say that this returns an integer and make changes accordingly. And sum um, smallest distance and return smallest distance here, and pair does not exist, and this is conflicting with the type that I have defined above, which is uh, what is it? It is this find shortest int, right? And yep, 18. This will not return an integer pair. Yep, this will just return an integer and smallest pair. Yep, distance is if it is less than current pair, then make smallest pair equals to I here, and to j in here, and to current pair, and then I don't have to free current pair, it is just an integer, and current pair, no, current distance. Copy this and select, paste current distance. Right, right. Current distance, and this will return the current distance. I will just these, return, return. What do I want to return? Return just forget it now. Oh yeah. I need to get a distance which is stored in the node. Forget it. I think I should change the way that I am storing the nodes. Instead of node, I can store it in a graph structure, which would be much better, much simpler to work with. Yep, instead of a node structure, I should store them in a graph structure. And for that, I will have to change literally like half of this code. Okay, let me just go to the washroom and I will be back, right back, and fill my water bottle with water. Yep. And you find that. And here, find shortest path. Yeah. The thing is that the way that I'm storing commands is very pathetic. And well, get hash, get a name. That is cool. That is all cool and stuff. But then I'm not using get name function. Global places strings. Yeah, yeah, I might use the global places string. Yep, this thing at some point. Current index. Yep, that is what that is also I'm also using that. Nodes. That is not what I want. I will store these things not in nodes but in uh let's say matrix. I will call it a grid of 30 by 30 integers, and it will be initialized to 0. All the values will be equal to 0 at the start. Give shortest path, get hash, and yep. What am I doing? I am first finding the thing with a find command and getting the command, which is cool. And am I mallocing something? Yes, I am mallocing a space for the command. And in the command, this is the structure for a command: place one, place two, and wait. That is good. That is good. Yep, command. And after getting the command, I am doing something. I do not need the node. I do not need this. Too many errors omitted. Stopping now. Okay, and since I do not need that, give shortest path. I don't I don't have to do this. Global nodes. Nope, 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 nope. What I can do instead is uh, go in global places string, and from there count out this, and the problem will be in execute command, and this is going to become much simpler. Now, given a command, I will do simply what I have to do is this uh, grid cmd dot or wait int uh, 1 equals I equals cmd dot place 1 and int j equals cmd dot place 2, right? And here I can just delete all of this, and here I can do I j equals int weight equals cmd dot weight. Int ij equals weight, and grid j I equals weight. That is it. That is all I had to do. Are there any other errors? Nope. There seem to be none. Right. Execute command. Yep, that is cool. This is cool. Then I get a pair, and I am going through stuff and find shortest path, which is this. Find shortest path, which is supposed to give me the shortest path if remaining count. If remaining count equal to 1, then I have to return from the grid, not I start to end, the direct distance from start to end, right? And if not that, remove this, by the way. and make this equal to return 0. Right, now if the count is 2 or something, when is the count 2? The count is 2 when, let's say, I am at some place like this, and well, if I am a place like this and the remaining count is 2, then the only path is fixed. So I don't have to call itself again. I can just send the sum this and this. So yeah, let me do this. Remaining count is 2. When it is 2, and don't just blindly return this. Make hint sum equals 0, right? And do not sum equals 0. Start to end. I do not want to go to start to end. I wanted to go to the node which is in the middle. That is the only node which is not contained in the empty in the visited. And there are only two nodes which are not in the visited: the current node that I currently am and the node that I want to go to. So I will do int middle. Yeah, no, node is fine. Middle node equals uh, nothing, and I'll go for int I int middle node, not int middle node, middle node equal, or wait, I can just go with I. That would be much simpler. Int I equals 0, I less than node count. Shit, I less than node count. Do I need node count? Fucking hell, I do need node count. So let me make node count a global variable. Int node count. It is equal to 0 and here and here. Where is here? I can do this, right? And if I less while I less than node count, go through yeah, yep, go through the visited array. Now if visited I equals 0 and visit and I does not equal to, where am I? I am at the end. If it does not equal to, and then middle node equals I. Right, now I have the middle node, and sum plus equals grid from start to middle node plus grid from middle node to end, and remove this and return, or yes, uh, yeah. And if the count is greater than if remaining count is greater than 2, then I will have to call the function recursively. Let's say I am at step this and the remaining count is 3, and now I have to call the function for this and for this. Yes, okay, I will do, yay. In this case, I will do int smallest sum equals 0. Wait, 0 will always be the smallest. How can I make this very big? Smallest sum. ChatGPT. In C, I want to initialize an integer to the greatest positive value. How do I do that without knowing how much bits an integer takes? Let's see and see you can initialize. Hmm, that is cool. That is cool. And max. Why is it undeclared? It is in limits. Uh, C limits does not exist in the standard library version that I have. And I'll just let's see. Does it give an error? Yep, it does fucking give an error. File not found. Okay. I am getting error that limits dot h. Oh wait, it is limits dot c limits. Is that oh, that doesn't limits dot h. Yep, that works. Does that compile? Yep, that does compile. That works. Now after getting that, I would like to do for int int I equals 0, I less than node count I plus plus. If visited visited I equals 0 and I is not equal to end, then make a copy of the visited and give it below. Fucking hell. I have to write a function which gives me a copy of the visited array. I'm lost. Uh, for int j equals 0, j less than j less than wait. I will be changing that. Yep. I don't have to create a copy every time. I can just create a copy here. Int visited copy is an array of node counts element, right? And for int I equals 0, I less than node count I plus plus, I will do visited copy bracket I equals to visited bracket I. Yo, that is cool. And in here I want to make a little change in the visited thing. uh, Visited copy bracket I equals to 1, right? I have I equals to 1. Afterwards, I can change it back to 0 and use this again, right? Will this cause problem? Fucking hell. This might cause problem because I will be no, no. I don't think this will. This should be okay. This should be okay. I don't have to care about what will happen inside. This is cool. Yes, this is cool. This is okay. Now, if it is not equal to end, then I want to find out the sum of int c current sum equals. I want to call the function to find shortest path. Well, the start is just equal to the start, and end is equal to the current place I, and visited is visited copy, and remaining count is remaining count minus 1. Why is this an error? Incompatible type int node count passing to character pointer. What the unsigned you cha. That should be cool. Now if c current sum less than smallest sum, then and yeah, I would less than no. The smallest sum is greatest, but the current sum is equal to this thing, and current sum plus equals to grid to get to n from I, right? And if this is the case, if the current sum is smaller than the smallest, then I'll do smallest sum equal to current sum. I will do this for every unvisited node which is not equal to the end node, and I am making the end node visited. Fucking I am a retard. Yes, I have to make end visited, and then I will do visited copy end equals 0. Wait, I'm absolutely a retard. Visited end equals 1 and just call it. Is that correct? So visited end equals 1. Yes, and when I pass this in, it will make some changes to my code, and I do not want to lose those changes to this visited array. Uh, yeah, fucking hell. Every recursive loop will make its own changes to the visited array, which I do not want to happen. Why do I not want it to happen? I do not want it happen because that would mess up the flow. That would mess up things. So yeah, the best thing would be to malloc and get a new visited array every time that I encounter something like this. which is just malloc or on the heap, or I can get it on the stack, which is also cool. Right, it is cool. So integer or uchar visited copy equals an array of size node count, right, and initially all of them are equal to 0. Now for int j equals 0, j less than node count, and j plus plus value visited copy bracket j equals visited bracket j, and node yep, I will have to malloc because this is a variable size, and variable size arrays can't be allocated like that automatically. Because integer, this will store, fucking hell, an integer pointer. Yep, that is what an array is. Visited copy equals int integer malloc. Now node count multiply by size of uchar, that would be cool. Uchar pointer, that is also unsigned char pointer, and that is also unsigned char pointer. I will pass the visited copy after creating it. I will pass it in. It just took me 3 lines to create it, and then pass it in. If I will check the current sum, if it is greater, then okay. If not, then okay. And at the end, I will free visited copy. Right? Is that cool? That is cool. That should work. And at the end, I can just do smallest return smallest sum. Fuck. I don't know. Will this work? I don't know. Shit. What am I printing here? I am printing a start, end, and distance. Error. Wrong. Yeah, distance is wrong. Distance is too fucking much. There is like absolutely too much distance. That breaks all bounds. Fuck. Is it? Fucking hell. Let me try to print the array after I have created it. Give shortest path. Yes, after this here. Let me do for int I equals 0, I less than node count, and I plus plus, and inside for int j equals 0, j less than node count, j plus plus. And what do I want to print? So first of all, put char, an opening bracket, of course, and inside I'll do the same here before printing everything, and then inside I will do printf %d comma, no new line, and in here grid ij right, and then put a new printf, printf, closing brace and a new line, right? And at the end, after this, do the same. Now, is the grid correct? Grid looks like this. 0, 1, and that seems pretty much correct. Let me fashion it a bit better. Where am I printing the grid? Here I am printing the grid, and do this, do printf with an opening brace and a new line, right, and semicolon, of course, and do this, but also do printf, a tab, and an opening brace, a tab and an opening brace. That would be cool. That would be cool. That would be cool. And after this and a new line, right? And print digits using 3 digits. Print distances using 4 numbers. Out. Right. So grid is correct, right? The grid is correct. Grid seems to be correct. Then what is causing the error and how much time has it been? It has been 2 hours and 23 minutes, which is cool. Grid is correct, right? Is it? Yep, it is. Hint. Yeah, and it seems to be correct. The grid seems to be correct. Yeah. Yeah. So the problem. Where is the problem? In this, let me do printf shortest distance. Let me do wait, I can just print what I am printing in here. Here, after getting every update, we'll do this. Whenever I see an update, instead of answer, this is the smallest pair, and smallest pair. Lang / out. Okay, it just updated twice. This is wrong. This is wrong. This is wrong. Max int. Fucking hell. Is it because of max int? Fucking hell. Where was it? Where was max int? Max int. Oh, there it is, bastard. Let me print this. It could be because of this. Max int is equal to, I think this is so maximum that it is going to 2's complement and being printed as a negative value. Smallest sum. The max int, nope, it is pretty much positive. But why do I see something like this? Something like this. Something like this. Why my accent is good. It is positive. Why am I seeing this? 214 748 214 748 353647. I do not want to stretch this till tomorrow. I want to get this done today. So let's not waste time and actually do this. So maximum int is correct. No problem with that. Okay. Where is the problem? Where is the problem? Is it this find a smallest path function which is causing the problem? Let me do here and print start and distance for every single time that I'm calling it. Start is I, and end is j. Smallest path, as it turns out, is current distance. Now let's see, I will see a lot of things being printed. Yep, from 0 to 1, the smallest path is this. From 0 to 2, the smallest path is this. Okay, yeah, yeah. It hallucinates when I go from 5 to 6, and 5 to 7, 6 to 7, and 5 to 6. Wait, why am I doing that? 4 to 5, okay. 4 to 6, 4 to 7, okay. 5 to 6, and 5 to 7, okay. And then 6 to 7. That should be it. Why am I calling it? Oh, this is the answer, okay. I'm not calling it. But why is 5 to 6 this number? And 4 to 7 is 183, which is suspiciously small. 4, 0, 1, 2, 3, 4. 2, 7, 0, 1, 2, 3, 4, 5, 6, 7. Ah, which is seems like it is working, but it is not working for 5 to 6. Why? 5. Okay, I should not call this function when the numbers are same. For like 0, 0, for 0, 0, 5 to 6 is giving me error. Oh, 5 to 6 is the first one that is messing me up, and then 5 to 7 is also messing me up. Is there something, a global thing, which is being messed up whenever I call the find distance function? 5 to 6, 5 to 6, why is 5 to 6 messing up? It will also print the visit, well, the visited is cool, visited array. Wait. Visited, is it the visited that is causing the error? Unsure, I declare one here, which is cool. I'm declaring one here, which is cool, and then I am doing that and that. Node count is that. Node count is also good. Ever no. Why is 5 to 6 giving me such a negative number? Is it? Oh, I take smallest is into max, right? And when is it that I am using into max? Smallest current, smallest sum, right? And smallest sum, smallest sum, current sum plus grid. Maybe it grew too much that this overflowed, this part going from 5 to 6. So let me use unsigned integers for this. That might be the case. And this is messing up. Type def unsigned int will be called uint. Oh, spelling is wrong. UNSIGNED. Unsigned int will be called uint, and it will mean the sum. So it will change this u uh, um uint. This will become unsigned int. Okay, typed this before actually using it, right? And is there something that I should change here? Nope. Char, that seems good. Integer index node count is okay. Yeah, good. This no, no. This is cool. This is cool. Pair pointer, a function that returns a pair. Give hash that gives the hash. Get name. Find command gives a command. Yeah, that is cool. And void execute a command. Find shortest path. Yep, this will return an unsigned int, which is the new thing now, right? Right, right, right. Answer gives shortest path pointed to a pair. And in here, what? Yep, I got the line there. Put them there. Yep, yep, yep. Distance. Printing start, print, end, unchar, uchar. Yep, yeah, yeah. This becomes unsigned character and unsigned integer, and sum also becomes unsigned integer. And here, u integer, u integer, yes. And what else needs to be changed to unsigned integer? Yep, current sum. And yeah, that seems like it should break at the first time. Smallest distance turns out to be 0 when I go from 0 to 0. This is humanly not possible. Yep, this is not possible. This should not be allowed to happen. I need a way to check my answers. So let me use the test case from here. And part1.c, and we split test.txt, paste this, go to the left and change the file name from text to test. And let's see. That is messed up. That is messed up. That is absolutely messed up. To go from 0 to 2 or even to 1, the distance is this. Which is messed up, which is messed up, which is messed up. Why is this happening? From 0 to 2. Okay, that is when the remaining number of nodes is 2. When the remaining number of. When is it 2 actually? When is it 2? I start with here, there are 5. I start with n minus 2, that is 5 minus 2, 3. When I, let's say, call the find shortest function from this to this 3, and when I call this, I will reduce 1 again, and I will have 2 remaining nodes. So in the 2 remaining nodes, when there are, like, I cannot go to here, here, or here, the only path is this, and I think that might be causing problem. What do I do? I want to find the middle node. Yep, I want to find out the middle node. Yep, but uh, yeah, yeah. Is it the way that I am creating the visited node? Nope, 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 nope. Is it? And does the problem lie in the visited node? Let's see. Printf visited is well. I know I can just do this brute force. %d, 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 because I know the number of nodes is 7. So this whole visited, or I can just be a little, put a little brain, a bit of brain, and for int I equals 0, I less than 7, or node count. Yeah, let's make it good. Printf %d comma and visited bracket I, and at the end printf closing bracket and new line. Okay, the first case I got visited 1 1 and 150 due to some reason. Garbage values. Fucking hell. I'm getting garbage values. Garbage values. I am getting garbage values. Where? Yep, here. Fucking hell. Yep, garbage value. And I equals. No, wait. Where am I originally declaring it? Yep, here. U char pointer visited equals U char pointer malloc and node count multiply by size of U char, and do this and do for int I is I okay, no, let's use k for int k equals 0, k less than node count k plus plus, do visited visited k equals 0. Right, okay, now this should work. It does not. Well, the visited part is fixed at least. 110 why is it being printed twice? Why is it being why is it being printed twice? Let's see. Find shortest path. Find shortest path. Here I am calling find shortest path only once. Yes, but why is it being printed twice? Let me go AOC error code cd day9 ls dot slash out. Here it is. This is being printed twice, and then I do start. When am I printing this start and end thing? I am not printing it here, right? I am printing it here. So when I call this, I print it. And what is the remaining count? Remaining count has to be 2. Yes, I will also print the remaining count then. Printf remaining count, no, count %t new line print, not to just print remaining count and part1 dot slash out clang dot slash out. Remaining count is 1. Why? Why? Yes, that is an edge case, isn't it? That certainly is an edge case, but I won't be seeing it now if I do this for my main file. If I do this for like, yeah, if I do this for the main file, I should not see it. And at the end, I see that the answer is, what is it? It is, wait, why am I seeing start and distance 0, 0 for that one particular case? And printf, yes, let me just, nope, this is what I want to print. Make this go away. Let's remove, comment this out, comment this out, comment this out, um, comment this out, and yeah, line dot slash out. The answer is 0. Beautiful, beautiful, beautiful. Why is it 0? Give shortest path. All right. I'm returning smallest pair. Yeah. Current distance. Let me print every time that this happens. Lang dot slash out. Okay. Current distance is being initialized at some place which it should not be initialized at. Okay. Give shortest path. Smallest pair. Malloc. Yep. Let's do smallest pair dot distance equals to max int, and that was the thing, int max. Okay, int max. This might work. Not see limits. Okay, clang dot slash out. Let's see, and what do I get? I get 120 as the answer. Let me check for my test case. Fx clang dot slash out Yes, okay, test case. In test case, there is a edge case. Edge case, yes, yes, yes. In test case, there is a problem. Execute command, find the smallest distance if this equal to or less than. That is it. That is all I had to do. And now the test case will also work. 605 is the answer given to me by the test case, which is actually the answer. I can comment this out, save it. Yep, of course, save it. 605, which is the answer given to me by the test case, and that is correct. Now let me do this for the actual thing, for the text. Okay, the answer comes out to be 120. Let's see. Let's see. I'm not very optimistic, but I am very optimistic in this case. That is wrong. That is wrong. Your answer is too low. Yes, it seems to be too low. It is working for test case though. It is working for the test case though. And what does it say when I go from 6 to 7? The distance is 1. I guess the literal distance is 120 between 6 and 7. Okay, yeah, yeah. Save out. Okay, between 6 is this, 7 is this. It is 70. It is not. Is 0. Wait, 6, 7. Yeah, 6 is this, 7 is this. It is 70, not 120. 70. And that is actually too low. That should not happen. If I go from 0 to 1, the distance is 194. 0 to 1, the distance is 194. I am not calculating this properly. I am messing somewhere in the find shortest path thing. Yeah, current sum. Right. This end case works fine, but this smallest sum starts at a very big number. Then I wait. Why am I creating node copy here? Right, and let me go to the washroom for a minute. This is cool. We are going to do this today. Wait. Yep. Mute. Yep, I am back. I drank some water here. Now, the problem is in this part, the shortest distance. Here, wait, nope. The problem is in this part. find smallest path. Yep. Okay, I initialize a smallest sum to the maximum number an integer can take, and then wait, can I do unsigned int max? That is, maybe I got some error above. Nope. Fine, 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 fine. Yep. Now I will start at index 0 till uh, the total number of nodes. And if I have a node which is not visited, that is visited equals 0, and it is not equal to the end node, because end node is, yes, because end node is the node that I want, that I currently am at. Yes, end node is my current node and it is not visited. So if that happens, then I will first of all create a copy of the visited node by mallocing, and then this, and then visited copy equals this. Right, 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 right. Yep, yep. Visited copy equals this. Yes. Why was this not causing a lot more problems? This should have caused a lot of problems, but this did not. Yes, at the end I free this. Now, now. Current sum. I get the current sum from find smallest path, where I start and get to I, one of the unvisited nodes, right? And I pass in the visited copy and I do a remaining count -1. Count becomes -1, right? And that is why it was ending, because I was doing count -1. Yeah. And seems like this should work. Okay, what the heck? Lang dot slash out. Sorry, 153, which is like fucking even lower. No, which is a bit higher than the one I submitted last time. Please wait 1 minute. Okay, if I submit now, I will have to wait more than 1 minute, I guess. 153. Am I optimistic about this? This might. Your answer is too low. Yes, of course it is too low. It is like on the face. Yes, it is too low. Too low. It has to be like at least 300-400 or something. Yes, if I do this, I do that. Right, current sum plus equal to how to get to the end, the current place from the grid. I add that to the current sum, and if current sum less than the smallest sum, I make smallest sum equal to current sum, right? And at the end, I am returning smallest sum. Hmm, 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 hmm. This should work. This should be actually working. Fucking hell. What does I represent? I represents the index of the node which is not visited. If I equal to 0, that is, it is not visited. Then do this. How much time, how much weight will it take, distance will it take to get from the start to the I node when the nodes that I have visited is this, and remaining count is like -1, -1. remaining count less than equal to 2. Yes, that is correct. And here it is node minus 2. Fuck. And then if current distance equal to find shortest. Yeah, that should fucking work. Let me print this here for every node. For every node, that is the distances are too small, are just too fucking small to be considered correct. The distances are too small. Let me do this for the test case. For the test case. For the test case. Replace this with test. Let's see. Okay, here the distances are actually correct and make sense. What is causing the problem? Find shortest path. I go till here when a remaining count is less than or equal to 2 and I return this, right? And here when visited is 3 at some point, I get that number in here, current sum, and I add to current sum grid I to end. That is how to get from I to end, and I is not equal to end. Yes, I is not equal to end. I is not equal to end. And I add that to the current sum, and I check the current sum with the smallest sum. And do that with every single node at any level. This at some place I am messing up something. I am messing up something. I am messing up something. Let me print these also. Dot slash out. Let's see. Okay, quite a bit of stuff. And yeah, no. Okay, to go from 5 to 7, I have reached. Wait, what? Count is 6. Count is 6. 6. Yes, 5 and 7 should be. Wait, visited. This is 0, 1, 2, 3, 4, 5. This should be 1, but 6 is 1 instead. And then okay, visited is not okay. Visited is not cool when count equals to visited is not being updated properly. Mhm, mhm. What is the initial visited thing that I'm sending? Okay, let me copy and paste this here whenever I. Wait a minute. No, 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 no. I am getting some space here, and then at the end, and I am being visited. And after that, I would like to print visited like that. No, 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 no. Does this make sense? Yes. Okay. Okay. I was somewhere else. Dot slash out. What is the visited? Visited is when wanting to go from 0 to 1. Visited is this. When from 0 to 2, it is this. 2, 3, 4, 5, 6, 7, 8. Wait. 8, 8. Starting from 0 till index 7. Right. And well, the initial visited seems to be correct. From 5 to up. Not always. Not always. When it is, let's say, from 1 to 4. I go 0, 1, 2, 3, 4. That is correct. From 3 to 7. 0, 1, 2, 3 till 7 is the last. Okay. From 5. 5 is this. And 6 is this. 5 and 7. At 5 is this. 7 is this. Right. Right, right, right. 5 till 7. 5 is this. 7 is this. And what is this? From 6 to 7. Yep, 6 to 7. That is cool. So visited is, well, at least passed down correctly, but it might be messing up inside this function when I am recreating the visited by creating a copy of it. J starts from 0 till a node count. Uh, yeah, and visited J equals the original J, and at the end visited copy and equals 0. Should be good. And the remaining count becomes remaining count minus 1. I'm passing down, I'm taking in one visited and changing it. Yep, every call to this function gets its own visited array, which is cool, which is okay and amazing. And I guess it has been more than 3 fucking hours me trying to solve this question. And wait a minute. Well, I guess that was a cool exercise that we did with all of this, and in the end, I was unable to solve this. But the thing is that I was at it and I wrote like 200 lines of code, and maybe I will do this on my free time, which is another way of saying that I will not do this. And I don't know, I might do this at some point. But for now, this is it, and tomorrow I will start doing day 10. And why is this good? Because I know how this thing works, and I can move on to the next thing without wasting too much time on being stuck on one thing. And it is much better to get experience from different things than spending a lot of time on a single thing and getting good at it. Yeah. Question number day number 10's question would be in a different way, and I will see this seems like doable. This seems like a fucking doable. Okay, bye. That was it for today. Yep.